Okay, so here we are with the exercise worksheet, exercises on area of planar regions. The instructions at the top tell us to find the areas of the following planar regions and to sketch each region. We did question 1 in a previous video, so we're going to scroll down to question 2 here. So now we're going to do this question 2, which reads, the region in the third quadrant bounded by y equals x, y is equal to 8 over x minus 2, and the y-axis. So if we're in the third quadrant, let's set up our axes so that the third quadrant is most visible. Y is equal to x is the bisector, the straight line that goes through the origin that bisects the first and the third quadrants. 8 over x minus 2 is a rational function, and it has an asymptote. It's going to have a vertical asymptote at x equals 2, and so that function is going to approach kind of up like this, which is not so much what we're interested in. We're interested in the part on the left-hand side, which is going to come down like this. So here is our curve. Y is 8 over x minus 2, and the y-axis, which is already drawn. So the region that we are looking for is the region bounded here that I'm outlining in gray between these three curves. So now we can see quite clearly that our top function is y is equal to x, and our bottom function is the rational function here. So this is the bottom. We need to find the left value and the right value. Well, the right value, which we usually call b, is obvious. Again, it is 0. This value, though, is a point of intersection that we need to find. The a value is the intersection of the rational and the straight line. So let's set up an equation to find the points of intersection of those two. If we cross multiply up, x squared minus 2x is equal to 8, or x squared minus 2x minus 8 equals 0. So let's factor this. If we factor, we're going to get x, we need a negative for the 4, and x plus 2, which is telling me that there's two solutions to this, x equals 4 and x equals minus 2. X equals 4 is the solution that would be, well, somewhere over in the first quadrant, right? Somewhere over here. That's not what we're looking for. So we want the solution that is in the third quadrant, x is equal to minus 2, so there is our a value. So we're going to do the exact same thing that we did in the last problem. We're going to look at the area by using the formula, the area from a to b of the top function minus the bottom function of x dx. And so if we set this up, we now have our a value as minus 2 here, our b value as 0. Our top function is the line y equals x, and our bottom function is the rational 8 over x minus 2. So we're going to do this integral as set up here. So the first part is going to be easy. We're going to set up or split the integral. We need an antiderivative of x, and so we need 1/2 x squared, and that is going to be evaluated from minus 2 to 0. The second one is a substitution that we might be able to do in our heads, but let's write it down. So the second one is going to be, I pulled out the 8, so we're going to need to substitute x minus 2. So let's do that on the side here. So we're going to let u equal x minus 2. Du then is going to be dx. We have to remember this is a definite integral, so we're going to change our bounds. When x is equal to minus 2, u is x minus 2, so u is minus 2 minus 2, that's minus 4. When x is 0, u is 0 minus 2, so that is minus 2. So this is going to give me, I'll just recopy this one. We'll evaluate everything in just a moment here. So from minus 2 to 0 again, 8 times the integral. I'm going to rewrite my new bounds. So my new bounds are in terms of u now. These are u values from minus 4 to minus 2 of 1 over u du. That's an antiderivative, which is now one of the basic ones. It's one of the Cal 1 derivative rules backwards, so we can take that immediately with no further work. So we know that's going to give us the ln of the absolute value of u, evaluated from minus 4 to minus 2, and now we can run through using FTC2, do the top value minus the bottom value. So the first one here is going to be 1/2 of 0 squared minus 1/2 of minus 2 squared minus 8 times, and now we see where the absolute values come in nice and useful in the logarithm function. So again, the top value, ln of the absolute value of minus 2 minus ln of the absolute value of minus 4. And lastly, then, we're going to simplify what's here. So this first one, the first part obviously goes away, and so I'm going to get minus 1/2 times 2 squared is 4, minus 8 times, evaluate the absolute values, ln of 2, minus the ln of 4, but I'm going to write that as ln of 2 squared, and the reason for that is I'm going to use a law of logarithms to bring that down in front. So we're going to have minus 1/2 times 4 is minus 2, minus 8 times ln 2 minus 2 ln 2. So that's going to be minus 2 minus 8 times 1 ln 2 minus 2 ln 2 is minus 1 ln 2. And then we're going to have negative negative, so 8 ln 2 minus 2 is our final answer, and these are, of course, units squared.